Screen is visible to all?
Visible, sir. Visible, sir.
Okay, okay. One second. One second, just a minute. Okay. So this plant is given here. Okay. And this is the compensator. So what should be the phase margin of plant? That already we know how we can calculate. So phase margin we can calculate at the gain crossover frequency. Okay. And what is the gain crossover frequency? So gain crossover frequency is the frequency at which the magnitude should be equal to 1 or 0 dB. Okay. So we can just equate it to 1, 10 divided by this omega into omega square plus 10 square. This should be equal to 1. Okay. So it will be omega into omega square into omega square plus 10 square. It will be equal to 100. Is it correct? So omega to the power 4 is equal to 1. Omega to the power 4 plus what is this? 1 second. So both side I am just doing a square. Omega square into omega square plus 10 square. It will come this side and it is equal to 100. So omega to the power 4 plus omega plus 100 omega square minus 100 is equal to 0. Is it correct? So omega we can assume as t. So t square whole like omega square t I am assuming. So that will be t square and plus 100t minus 100 is equal to 0. Is it clear up to now? So we can solve this quadratic equation. We'll find two value of t. Okay. So mode and quadratic equation we can solve. So as square plus bx plus c, where a is equal to 1. 100 minus 100. So t value I am getting as 0.99. T is equal to 0.99 and another value I am getting minus 100. So that is not correct. So 0.99, what will be the omega value? So omega square is equal to t. So omega will be under root t and under root 0.9901 will be under root 0.9901, 0.995. So gain crossover frequency is equal to 0.995. Is it clear to all up to now? This will be the gain crossover frequency. So what will be the phase margin? Phase margin is equal to 180 plus GS at omega GC. Okay. So what will be the angle at omega GC? That will be angle will be minus 90 minus tan inverse 10 by 0.995, 10 by omega by 10. So omega by 10. This 10 plus j omega, so omega by 10. So minus 90 minus tan inverse 0.995 by 10. How much will be this angle? Minus 90 minus tan inverse 0.995 divided by 10. So this is 95.68. This angle is minus 95.68. So if you add this angle in 180, that will be the phase margin. So phase margin will be 180 plus minus 95.68. How much we are getting? 84.31. 84.31 is the phase margin. First answer. Is it clear to all?
Yes, sir.
All of you have installed MATLAB, like you are doing MATLAB also. I will just show the board of this one, how will do it in MATLAB. Okay, so is it visible to all this
Yes,
screen?
sir. Yes, sir. Yes, visible, sir.
Okay, so the transfer function is 10 divided by s into s plus 10. Okay, so first to define the transfer function, we'll write syntax like this: s is equal to tf, then this bracket will be there, and like this hyphen and s will write in s will be defined as a, so we can write any transfer function in terms of s. Okay, so I have written here g, so g is a system transfer function 10 divided by s into s plus 10, and margin means it will give Bode plot, or in place of margin we can write Bode also, but if you write margin then it will show gain margin and phase margin on the same Bode plot. Okay, so I'm going to run it. See how much we are getting: 83.4 degree at 0.995 radian. Okay, already we have calculated how much: 84.3, and what was the omega gc that we have calculated? This is equal to 0.995. Then it is correct. So you should, all of you should use MATLAB also, then you can verify the answer. Like if top question will be there, like you are getting some doubt, so you can solve by basic method also, and you can solve it by MATLAB. Is it clear to all up to now? So should we do the next question?
Yes, sir.
Okay, so this is the second part of this only. So we have decided that GC of S is equal to K. Find the value of K such that the phase margin will be 50 degree. Okay, so we have to find the value of K. This GC of S is equal to K, and what should be the K such that phase margin will be 50 degree. Okay, so first how we will solve this? For 50 degree phase margin, we'll find the some frequency. At that particular frequency, what should be the gain value? Gain value should be equal to 1. Okay, so first I will show it with Bode plot, then I will solve it by mathematically. Okay, so phase margin should be 50 degree. Okay, so phase margin should be 50 degree means what should be the angle of, let's say total transfer function will be, total T will be K into 10 divided by S into S plus 10. This will be the total transfer function. Okay, so our phase margin required is 50 degree. So 180 degree plus some angle at omega gc, this should be equal to 50 degree. So what should be the angle at omega gc? That angle should be 150 minus 180. So that angle should be minus 1
Minus one.
130.
1.
Correct? So we'll see in the Bode plot. Okay. So here we'll see the angle. So how we'll see, tool, we'll go in tools, then data tip will go. Okay, then we'll put in this plot. Okay, so and here on tool is selection style, will say mouse position. So now we'll move it, we'll go to minus 130. Okay, so minus 130, how much frequency we are getting? 8.51 rate.
8.51.
Okay. So same thing we'll do in magnitude plus also. Okay, we'll see the what will be the magnitude at that point. So here also 8.51 will reach 8 point, 1 second, 1 second. Okay, 8.5. So minus 21. Okay, it means that this should be our phase value. So at this frequency our magnitude should be 0. So how much magnitude should be added by the K value? So that should
Minus
be,
21.
no, plus 21. If we'll add plus 20, then it will become 0. Okay, so that K should contribute a gain of how much? Plus 21. Is it clear?
Yes, sir. Yes, sir.
So let's see. So
Yes, sir. Clear, sir.
hmm. So that should be how we can K, 20 log K should be equal to how much? 20 log K should be equal to 21. Is it correct? Because K should contribute a gain of 21. So from here we can find the K value. What will be the K value? K will be equal to 10 to the power 21 by 20. Is it
So
correct?
11.22.
11.22 we are getting 10 to the power.
11.22, sir.
Okay, I am also calculating 21 by 20. Okay, 11.22. 11.22. One second, I have the answer also. I will also check whether it is correct or not. Okay, so some almost 11, 10.9 we are getting. So some maybe some point calculation is there. Okay, I think this that one thing we have missed now, like exact value we have not seen there in the Bode diagram. We have seen some here this 8.5 we have seen. So what will be the 8.51? Minor also will be there. Then also 8 point. Okay, minus 20, 8.5 minus 20. Okay, 11.33 we are getting. 11.22. So we'll solve it by basic method also. Okay. So one second. So what should be the magnitude at this K value? So 10K, okay, 10K divided by S into S plus 10. And what is our this frequency? This angle minus 130 degree. Okay. So at minus 130 degree, first what we will do? We will calculate the that omega. Okay. So minus 90 minus tan inverse omega by 10 is equal to how much? Minus 130. Is it correct? So what should be the omega value from here? Is it clear up to now? Omega we have already solved in MATLAB also. So MATLAB here also we can see minus 90 minus this one. This should be equal to how much angle should be? Minus 130. Then only it will be a 50 degree of phase margin. Is it clear up to now? Phase margin is 50 degree required. So angle contribution should be uh, one second. Angle should be minus this at that omega value. Okay. So what will be that omega value that we'll calculate here? So tan inverse omega by 10 is equal to how much? 130 minus 90. How much?
Minus 40.
No, it will
Minus
be
40.
okay. So all minus I am cancelling. It will be 40. Okay. So tan 40 omega by 10 is equal to tan 40 and omega will be equal to 10 into tan 40. So 10 into tan 40.
8.390.
Okay. So
Omega
omega is equal to 8.0.
8.390.
Okay. So at this value, our magnitude should be equal to 1. Okay. So what will be the magnitude? Magnitude will be 10 into K divided by omega into omega square plus 10. One second. Okay. So at omega already we have calculated 8.3. So that will be omega is equal to 8.390. This should be equal to 1. Then only total, this is total magnitude including K value. Okay. Including the K value, the total magnitude should be equal to 1. Then only 20 log magnitude will be equal to 0 dB. Is it clear up to now? So 10K divided by 8.390 into 8.390 square plus 10. Okay, I think it should be 10 square 100. Correct?
Plus 7.523 K value.
K value how much we are getting? 7 point.
523.
Any mistake is there? We can do it once. So K will be equal to 8.390. I think you have missed this 10 square. 10 you have kept in place of this. See, 10K divided by omega into omega j omega plus 10. Okay, so s is equal to j omega. Magnitude here, magnitude will be omega, the omega square plus 100 under root. Omega we know this 8.3. You check once calculation, maybe some mistake will be there. So into 8.390 square plus 100 divided by 10, correct? 8.390 into under root 8.390 square plus 100 divided by 10. Is it incorrect? Something, one second. 8.390. How much we are getting? Okay, 100 square I have. 10.95. Is it correct? 10.95. Is it correct? And with Bode also we got 11.22, almost same. Bode, I think that is more accurate. That will solve like at, because here we are taking just 3 points, 3 points. That will take at more decimal points. Okay, that's why that Bode is more accurate. Is it clear? Hello. I
Yes,
have,
sir.
okay. So this value also we have calculated. Omega is equal to 8.390. At minus 130 degree we have seen there in the MATLAB that it was minus 130, how much? 8.51, almost same. Okay, 8.51, 8.39, almost same. Okay, should I move to the next question? Or any doubt is there, you can ask till now. All of you have installed MATLAB? Like in your college it is there, subscription? Hello, anyone reply? Should I move to the next question? Hello.
Yes, sir.
Okay, okay, okay. So,
Yes, sir. MATLAB is there.
okay. So what should be the settling time or 2% tolerance? Okay. So already K value we have calculated. So K 10K divided by S into S plus 10. S into S plus 10. This is our plant. This will be the plant with compensator. Okay. And here unity feedback is there. So we have to calculate the settling time. So what will be the transfer function? C by R will be equal to 10K divided by S square plus 10S plus 10K. Okay. And for 2%, what will be the settling time? 4 tau. That will be 4 divided by zeta omega n. Okay. And 2 zeta omega n is equal to 10 here. So zeta omega n will be equal to 5. So what will be the settling time? Settling time will be equal to 4 by 5. So it will be equal to 0.8 second. Is it clear to all? I think all of you know this formula. Okay, so moving to the next question. Anyone where you have doubt, you can stop me and ask. Okay. So, same question, what we are doing, we are adding some other type of compensator. So this pole 0 will cancel. Our actual plant transfer function was 10 divided by S into S plus 10. That was G. But some other compensator we are using to cancel out the pole. So such that the phase margin will be 50 degree only. Okay. So pole 0 will be cancelled. So if this transfer GCF S will be there, what will be the G into GC? So G into GC will be equal to, this will multiply. So that will be T into 10, okay, divided by this S plus 10 will be cancelled. S into S plus 20. Now same thing we have to do for 50° of phase margin. Okay, what will be the value of T? Okay, so here also we'll do the same thing. So 50° means it should be angle contribution should be minus 130. Okay, so minus 90 minus tan inverse omega by 20. Okay, this should be equal to minus 130. Is it correct? So this 50° phase margin at some omega, that omega is the gain crossover frequency, that omega, the angle contribution by the total should be equal to minus 130. Then only if you add 130, 180 minus 130, so the phase margin will be 50°. Okay, so I'm just equating the angle of the overall compensated function with minus 130. So tan inverse omega by 20 is equal to how much? 40. So omega is equal to 20 into tan 40. How much? 20 into tan 40. 16.78 we are getting. Is it correct? Hello.
Yes, sir, it's
Hello,
correct.
sir.
Okay. Okay. So after this, we'll do the same procedure. So the procedure is like this magnitude should be equal to 1. Okay. So T into 10 divided by this omega into omega square plus 20 square. Omega into omega square plus 20 square. That our gain crossover frequency was much 16.78. So at omega is equal to 16.78, this should be equal to 1. Okay, omega square plus, so this will calculate. So T will be equal to here 16.78 into under root 16.78 square plus 20 square, this divided by how much? 10. How much we are getting? All of you also can calculate with me. So 16.78 into 16.78 whole square plus 20 square divided by 10. 43.8 we are getting. Is it correct? 43.807. Is it correct? So we'll check once with Bode, MATLAB. Okay. Is it clear to all up to now? Should I go to the MATLAB?
Yes, sir.
Okay. Okay. So that also I have written here. One second. Let's say just R. So 10 divided by S into S plus 20. Okay. So we'll just do the Bode plot. One second. So at minus 130°, what should be the frequency? So we'll add the data tip. Okay. So minus 130° we should go. It's minus 1 not 2. So I think some mistake is there. Okay, so that value I have to change. It was 20 na. Uh, what is the function? So 10t divided by s into s plus 20. Correct. So the k value we have calculated. What was the frequency? Frequency was 16 only. We are getting 16 only. One second. So tools, data tip. One second. Okay. Minus 126, 127, 120, 130. 16.8. Already we have calculated the that value. That already we have calculated 16.8. 16.78. Okay, this value at minus 130 degree, minus 130 degree, 16.78. So here also we are getting the same 16.8. And what will be the magnitude at this point? So that also we'll see. 16.8. 1 second. 16.6, 16.8. So 16.8 we are getting minus 32.9. Okay. So minus 32.9. So what should be the angle contribution? So minus 32.9. Minus 32.9. So angle contribution should be 32.9. So 20 log K should be equal to 32.9 and K will be equal to 10 to the power 32.9 by 20. How much it will be? 10 to the power 32.9 divided by 20. We are getting 44.15, and here we have also calculated with this one. So 43.8, almost 44. Is it clear to all? So with Bode information also, if Bode information will be given, from there also indirectly we can calculate the K value. Is it clear to all? Any doubt is there?
No, sir.
Okay, okay. So for this one also, we can calculate the settling time. Okay. So settling time is for 2%, 4 tau, 4 tau, that will be 4 by zeta omega n, and the transfer function will be 10t divided by, 1 second, 10t divided by s into s plus 20, s into s plus 20, that will be, this will be the open loop transfer function, and CLTF will be 10t divided by s square plus 20s plus 10t. So 2 zeta omega n is equal to how much? 20, and zeta omega n will be equal to 10. So settling time for this case will be 4 divided by zeta omega n equal to 4 by 10 is 0.4. So if you'll see from the last case the settling time was how much? 0.8. But here we are cancelling one pole and doing this time kind of compensator. So what is happening? Our settling time is reduced to half. Okay, is it clear to all? So by you doing this type of compensation, what we are doing, we are reducing the settling time. Is it clear? Should I move to the next question? Okay. Is it clear to all?
అంతే సార్ ఇక్కడ
So what will be the reduction in settling time percentage? How much percentage it will reduce? This value we have to calculate. Initially it was 0.8 and now it
17
0.4. How much percentage reduction is there?
ఓకే ఓకే సార్
50
అది
per,
చాలా
it,
మానసికలాగా ఉంటుంది
it is reduced by how much? 50%. Is it correct? Initially it was 0.8. Now it is with new compensation. Now it is 0.4. Okay. So how much percentage reduction is happened? 50%. Is it clear? Hello. Should I move to the next question?
అవును చేశాడు
Okay. Okay.
కనబడలేదు సార్
So this is the next question. Any doubt till now? Like, you can stop me and ask. Okay. Okay. So this question also similar kind of analysis I am going to do. So this is the plant transfer function. Okay. GS is equal to K by S into 2S plus 1, 5S plus 1. So it is desired that the line compensated system meets the following specification. So KV is equal to 0.5 and next specification is phase margin is equal to 40 degree. So first question is, what is the gain required to meet the steady state specification KV? Okay. So that will be what is the kb? Kb is equal to limit s tends to 0 s square gs. Okay. So is it correct? S square gs or sgs? Kb will be sgs. Acceleration will be s square. So it is equal to limit s tends to 0 s into k by s into 2s plus 1, okay, into 5s plus 1. So this is should be equal to 0.5. Okay. So SS will cancel. So K will be equal to 0.5. Is it clear? K value will be equal to 0.5. So for KB is equal to 0.5, the required gain is equal to 0.5. Is it clear to all? Any doubt is there, you can ask. Should I move to the next question?
Yes, sir.
Oh, okay. So the gain crossover frequency of the adjusted gain we have to calculate. So what is the adjusted system? GFS is equal to K value we have calculated. K is equal to 0.5. So 0.5 divided by S into 2S plus 1, 5S plus 1. Okay. So GS will be S divided by 0.5 divided by S into 2S plus 1. Okay. And then 5S plus 1. So we have to calculate the gain crossover frequency. How we can calculate? The magnitude should be equal to 1. Okay. So what is the magnitude? Magnitude will be 0.5 divided by omega into under root 4 omega square plus 1 into under root 25 omega square plus 1. Okay. That should be equal to 1. So by solving this equation, we can find the gain crossover frequency. Okay. See once the term s into 2s plus 1, 5s plus 1. So 2 square, 4 omega square plus 1. Okay. So omega square we can assume some function. Let's say omega square is equal to x. Okay. So that will be, what will be the omega value? Omega will be under root x. So 0.5 divided by under root x into under root 4x plus 1 into under root 25x plus 1. This should be equal to 1. So if we'll do a square both the side, then we can write the modified equation. So 0.5 should be equal to, okay, x into 4x plus 1 into 25x plus 1. So 25x plus 1. Okay. So this will be equal to x into, okay, 100x square plus 29x, okay, plus 1 is equal to, so see here if you do the square, so 0.5 square also will be happen. So it will be 0.5 square to 0.25. Okay. 100 x cube plus 29x square plus x minus 0.25 should be equal to 0. So this kind of cubic equation we can solve using the calculator. But if in exam this calculator will not be there, then options we can match. Okay, whatever the options are given, okay, so options we can match. Out of 4 options, will use the omega, will do the x value, x is equal to omega square, okay, and that omega square will put here in this equation, and whichever will satisfy equal to 0, that will be the answer. Okay. So but I'm using calculator to solve it, so you can also use scientific calculator to solve it. So this cubic equation, a value is 100 plus 129, 1 minus 0.25. So I'm getting at x value is equal to 0.07054899. This is the first solution. 3 roots will be there, and second root is minus 0.18, okay, plus j 0.054, 0.054, and third is minus 0.18 plus, and he said it will minus, one second, minus 0.18 minus 0.054, minus is 0.054. So these two will be in valid solution, okay, and this is the valid solution. So what will be the omega value? So omega is equal to under root x. Omega is equal to under root x. Under root 0.07054899. Okay. So one second. 0.07054899. So we are getting 0.2656. 0.2656. Omega value will be, so this is the omega gain crossover. No, omega gain crossover of the adjusted system. Is it clear to all? So this will be the correct option. Is it clear? Now the next question is whether the system will be stable or unstable. So how we can comment on this one, whether it will be stable or unstable? What is the procedure? Can anyone tell? How we can find whether system is stable or not? What is the criteria? Can anyone reply? How we can comment that whether this will be stable or not? So we already find the gain crossover frequency. The next question is, it will be if the gain adjusted system is stable. So what will be the answer for this 8th question? Can anyone tell how we can comment on this?
Sir, phase crossover frequency should be greater than gain crossover frequency for this.
Omega PC should be greater than
Omega
omega
G.
GC. Okay, so we'll calculate the omega PC also. Okay, so let's calculate omega PC. So what will be how we can calculate the omega PC? Tan inverse of that angle phi will be equal to minus 180 degree. So for
Yes.
that, what will be the frequency? That will be the phase crossover frequency. Okay. So one second. Minus 90 minus tan inverse 2 omega minus tan inverse 5 omega. Okay. Minus 90 minus tan inverse 2 omega minus tan inverse 5 omega is equal to minus 180 degree. Is this correct? Minus 190 minus tan inverse 2 omega minus tan inverse 5 omega is equal to minus 180 degree. So tan inverse 2 omega plus tan inverse 5 omega equal to 90 degree. So this we can write as tan inverse 2 omega plus 5 omega divided by 1 minus 10 omega square is equal to 90. So to 90 this should be equal to 0. Okay, the tan 90 is equal to how much? Infinity. Is it correct? 90 tan how much it will be? Tan 90 it is infinity. So this should be equal to 0. 1 minus 10 omega square should be equal to 0 and omega square will be equal to how much? 1 by 10. Omega is equal to under root 1 by 10. So what you have told, this omega PC should be greater than omega GC. But omega GC how much we got? Omega GC 0.2656. Omega GC 0.2656. And what will be this value? 1 by under root 10. 1 second. 1 by 10. 0.316. So omega PC we are getting 0.316. 316. Correct? So that thing is following here. Omega PC is greater than omega GC. Correct. So stable. other method is also there, like gain margin, phase margin. So gain margin and phase margin both should be positive. If one of this will be negative, then our system will be unstable. So both should be positive. Okay. Is it clear to all? What will be the phase margin of this system? How we can calculate? So phase margin first I am going to calculate. So uh, 1 second. So 180 plus at omega GC. This is our omega GC. Okay. And this is the function. So 0.5 by s into 2s plus 1, 5 plus 1. 0.5 divided by s into 2s plus 1, 5s plus 1. Okay. And our omega GC how much? 0.2656. 0.2656. Okay. So what will be the phase margin? Phase margin will be 180 plus 5 at omega GC. Okay. So 180 and plus 5 will be minus 90 minus tan inverse 2 omega minus tan inverse 5 omega. Omega is equal to 0.2656. Okay. So 180 minus 90, that will be 90 minus tan inverse 2 into 0.2656 minus tan inverse 5 into 0.2656. How much it will be? Can anyone calculate? I'm also calculating. So it should come as positive. 90 minus tan inverse 2 into 0.2656, okay, minus tan inverse 5 into 0.2656. How much? 9 we are getting? 9 degree.
Yes, sir.
Okay. So similarly we can calculate the gain margin also. So what is the formula for gain margin? Can anyone
Sir,
tell?
I 20, no, minus 20 log magnitude of transfer
Magnitude
function.
G, Gs at omega PC, right?
Yes, sir.
Okay. So minus 20 into log 0.5 divided by this, first I will write. So S 2s plus 1, 5s plus 1. 0.5 divided by S into 2s plus 1, 5s plus 1. This is our transfer function. And omega PC is equal to how much? 0.316. Correct? This is 316. Once I will calculate once more. So 1 divided by 10 under root. Under root 1 by 10. 0.3162. Okay. So this is 0.3162. So at this value, this should be equal to how much? 0 dB? No, no. This, okay, this not 0 dB. At this value, whatever this value will calculate, that will be the gain margin. Okay. But minus 20 into log 0.5 by at 0.3162 into 2 into 0.3162. Okay. A square plus 1 into 5 into 0.3162 a square plus 1. Is it correct? So minus 20 into log 0.5 divided by 0.316 into under root 2 into 0.316 whole square plus 1 into under root 5 into 0.316 whole square plus 1. How much? 2.9 we are getting. 2.9 dB. Is it correct? All of you can use calculator and tell the value. 2.91. So minus 20 log. Is it correct?
Yes, sir.
Okay. So our gain margin is 2.91 dB and phase margin is How much we have calculated? And
Sir,
phase,
it is additional amount of margin that we can do without.
yes, if this much disturbance if we'll do in the system, this much gain disturbance, it will become stable. So this margin is there. Okay. So this
Okay.
much margin it can tolerate. So how much will be the gain margin and phase margin? That relatively system will be more stable. Higher the gain margin and phase margin, system will be more relatively stable. So a phase margin is 9 degree we got, and gain margin we got 2.9. So same thing we'll see in the Bode plot also, MATLAB. So let's go to that interface. So this is the transfer function. I think this one, second one, control T. That is Z1. Okay, so I'm putting here Z1, and this I'm commenting. So 0.5 divided S into 2S plus 1, 5S plus 1. Okay, so we'll see whatever we have calculated that is correct or not. See how much we are getting. That same answer we are getting here. So gain margin is equal to how much? 2.91 we calculated. Here we are getting 2.92 dB. Okay, at 0.316. So this one also we have calculated. And phase margin is equal to 9.01 degree at 0.266. So both the values are matching. Is it correct? I think correct only. Already we have calculated. So 0.266, 9.01 and 0.316, 2.92. Is it clear to all?
Yes, sir.
Okay, okay. So I'm moving to the next question. 1 second. Okay. So this is to meet the requirement. Okay, the phase margin, new gain crossover frequency. Okay, we have to design the new gain crossover frequency to meet the same phase margin. Okay, so how we can design this? Phase margin how much? 1 second. Phase margin requirement was given at initially. So 40 degree phase margin. Okay, so for this much phase margin, what should be the new gain crossover frequency? So how we can calculate this? So we'll see the Bode ones. First I will see the MATLAB, then we'll do by the normal method. So, so how much? 40 degrees. So what should be the total angle? Angle should be 1 second. Data T. So 40 degree, what should be the angle? For 40 degree, it should be 180 plus minus 140. Okay. So that will be contribute 40 degree phase margin. So angle should be minus 140. Minus 140. Is it correct? So at minus 140, what we are seeing, our frequency is 0.137. Is it clear? So actual question was our desired phase margin is 40 degree. Okay, first we have seen this, then our phase margin required is 40 degree. So for 40 degree, what should be the gain crossover frequency? Okay, so this is happening here. Okay, minus 140 angle is coming here. So 180 plus minus 140, that will be plus 40 degree. Okay, so this should be the frequency at which our magnitude should be the 0. Is it clear?
No, sir.
Not clear? 1 second, I'll show the question once. So see, to meet our actual requirement was phase margin was 40 degree. We have to achieve a phase margin of 40 degree. Okay. So new gain crossover frequency is approximately. Okay. So already we have calculated the gain crossover frequency without meeting that criteria. Okay. Normally we have calculated a gain crossover frequency for this system, but we have to achieve a a phase margin of 40 degree. Okay, so at 40 degree, how we can achieve? So 180 plus phi at omega gc. Okay, so at omega gc, what will be the angle? That will be equal to 40 degrees. So phi omega gc will be how much? Equal to 40 minus 180. So 40 minus 180, that will be minus 140. Okay, so at that point the angle should be, total angle should be minus 140. Okay, so same thing we have observed in the MATLAB plot, like I have just plotted. So angle we are getting minus 140 at this point. So this should be, we have to add some compensator or something such that the gain will become zero here. Okay, so if gain will become zero here, then this will be our angle at omega gc, and if this will be our angle at omega gc, then our gain phase margin will be 40 degree. Is it clear now?
Yes, sir.
Yes.
Oh, okay. So same thing we can calculate by mathematical calculation also. So how much we got the value? 0.137 we are getting. Okay. So we can calculate this one. So what should be the angle? Tan, and this phi should be equal to minus 140 degree. Okay. So our transfer function is 0.5 by s 2s plus 1, 5s plus 1. Okay. So angle will be minus 90 minus tan inverse 2 omega minus tan inverse, no, tan inverse or tan,
Sir, inverse.
inverse only, na, tan inverse a by b, theta is equal to tan, theta is equal to tan inverse a by b. So tan inverse, this one will be how much? 5 omega. Already we have calculated, na. Tan inverse 2 omega, tan inverse 5 omega. So that will be 5 omega. Tan inverse 5 omega is equal to minus 140. Correct? So tan inverse 2 omega plus tan inverse 5 omega is equal to how much? 50. Correct? So 2 omega plus 5 omega 1 minus 10 omega square. Oh,
Sir,
yes, you can ask. Hello, am I audible? Okay. So tan inverse 2 omega plus 5 1 minus 5 into 2 10 omega square is equal to 50. Any mistake is there? Okay. So 7 omega divided by 1 minus 10 omega square, correct? Is equal to tan 50. Now we have to solve this quadratic equation, I think. So 7 omega is equal to tan 50 into 1 minus 10 omega square. How much is the value of tan 50? So tan 50, 1.1917. Okay. So 7 omega into so is equal to 1.1917 into 1 minus 10 omega square. Correct. So this equation I am writing here. So equal to 1.1917 into 10 into 10. 11.917. Okay. So 7 omega is equal to 1.1917 minus 11.917 omega square. So 11.917 omega square plus 7 omega minus 1.1917 equal to 0. Is it correct? Any mistake is there or correct? This calculation is correct only. So I am solving this equation. 1 second. 11.917 and this 7 and minus 1.191 minus 1.1917. So omega value I am getting as omega is equal to 0.1378 and other value minus 0.725. So any options are not matching here. Hmm, 1 second.
Sir, I think option 1. No,
Option,
no, no.
this is incorrect. I think in this options, correct options are not there. So answer will be this only, 0.1378. Already we have seen in the MATLAB also. So omega GC will be equal to 0.1378. Already I will show you the MATLAB once more. 1 second.
Sir, what is KB? KB you have earlier calculated.
Which one? Which one?
KB earlier
KV.
is
Okay. So that was different specification. This one you are telling. So velocity constant. Okay. KV is equal to limit s tends to 0 SGS. This is steady state error concept. Okay. K
okay. Sir, it is in case of ramp input.
velocity error and what is the displacement, velocity and acceleration. Okay. So displacement is limit s tends to 0 GS. Velocity SGS and acceleration KA. I think KP, I think KA and KV. KV is equal to S square GS. No, KP, KV or KA. So K acceleration will be S square GS, velocity will be SGS, and normal that displacement will be there, that will be GS. I think already we have gone through this in the steady state chapter.
Yes, sir.
Okay, okay. So I'll show once the MATLAB plot how much we have calculated, 0.137. Okay. So at 0.137 we are getting the phase of minus 140, and here also we have calculated the same thing. So we got the phase of how much? 1 second. So this one 0.1378 we have calculated. At this value we are getting the phase margin of 40 degree. Is it clear to all? Hello. Should I move to the next question?
Sir.
Okay. Okay. So what will be the beta value? So we know that standard transfer function for the lag compensator. So G lag will be equal to S plus 1 by tau. Okay, this is the 0 and S plus 1 by beta tau. Okay, so how we can calculate the value of beta? We know the formula for the lag compensator. So what will be the M minimum? That will be equal to 20 log 1 upon beta. This one formula we know. So this should be equal to our that already we have calculated the omega this phase crossover frequency. Okay, required phase margin we have calculated the, so at that frequency the total magnitude should be equal to 0. Okay, so in that way only we can write one equation. So 20 log 1 upon beta, this should be equal to 20 log, okay, 1 upon gs. So this is the negative of the magnitude in the actual transfer function. So if this both will be 0, both will be equal, then at that part frequency of 0.137, that will cross the 0 dB line. Okay, that will become our phase crossover frequency. Is it clear? See, this we know on formula 20 log 1 by beta. This is magnitude for the this transfer function, minimum value. Okay, this value we should equate to 20 log 1 by GS, because we have observed that in that Bode plot I will show you once. Here I will see the magnitude plot. So tools and data tip, here we'll add one data tip. So at how much? 0.137. 0.137. Okay, so 0.137, some magnitude is here 9.25. Okay, so that same magnitude should be, that minus of that magnitude should be added by our this lag compensator, and lag compensator magnitude will be like this. That magnitude plot will be, it will come here like this, and it will go like this, lag compensator. So this magnitude should be added to that point to make it 0. Okay, so in that case 20 log 1 by beta, this magnitude 20 log 1 by beta, and this should be equal to this inverse. So inverse means it will be negative. Okay, is it clear now? See, this actual magnitude was positive in the Bode plot. Actual magnitude was the positive in the Bode plot, but we have to add negative magnitude here to make it 0. To make it 0, minus 9.25 should be added. Okay, so that's why 20 log 1 by beta, this magnitude of this our lag compensator, this should be equal to 20 log 1 upon GS. So 20 log 1 upon GS at omega is equal to 0.137. It means that the negative of that magnitude. Okay, is it clear? Hello? Any doubt is there, you can ask. Hello? Am I audible? Can anyone reply?
Yes, sir, you are audible.
Okay, okay. So why I am equating these two? Because this is the negative of magnitude. This will give, how much this will give? This will give minus 9.05. This is minus 9.05. Why? Because, is it clear? I think it will be clear. Because this will go in top, that minus, this is minus 1. So minus 20 log GS. This will be minus 20 log GS means minus 9.5. So indirectly I am equating the magnitude of our lag compensator to minus 9.5, such that if plus 9.5 and minus 9.5, it will become 0 dB. Okay, so then what we are doing, we are making 0.137 as our gain crossover frequency. Then only that will become our phase margin. Is it clear now to all? Why I am equating this one? To calculate the beta value. So log 1 upon beta is equal to how much? Log 1 upon GS. So 1 upon GS, how much will be the magnitude? This, what will be this value? 1 second. So log 1 upon beta is equal to log 1 by GS. Okay, and this magnitude will be there, omega, some omega value. So if we'll just remove the log from both the side, what will happen? 1 by beta is equal to mod 1 by GS. What will be the value? Beta will be equal to mod of that GS. Okay, so 1 second. Beta will be equal to mod of GS at omega is equal to 0.137. Is it clear to all till now? This beta value I am designing for this compensator. This beta will be such that the amplitude of the actual magnitude plot will become 0 at 0.137. Is it clear to all? So from here we can calculate the beta value. What will be the beta value? Beta will be magnitude of 1 by beta will be equal to magnitude of 1 by GS, and beta will be equal to magnitude of GS. Okay, so magnitude 0.5 divided by omega, how much? 0.137 into 2 into 0.137 whole square plus 1 into 5 into 0.137 whole square plus 1. How much will be this value? Just calculating this. So, 0.5 divided by 0.137. 137 into under root 2 into 0.137 whole square into 5 into 0.137 whole square plus 1. How much we are getting this value? 4. Can anyone tell what will be this value? 0.5 divided by omega. Omega is equal to 0.137. Anyone got the answer? Two point nine we are getting. 2.9. Anyone got this value? So beta will be equal to 2.9. Beta for the lag compensator. Lag compensator is 1 plus s plus 1 by tau divided by s plus 1 upon beta tau. So beta we have calculated. Beta is equal to 2.9. Is it clear to all? Any doubt is there? You can ask. Can anyone reply?
Yes, sir. No doubt.
Okay, okay. So same thing. Next question. So already we know the beta value. Okay. Zero of the lag compensator is 0.1 radian per second. Okay. So 0 is 0.1. The corner frequency of pole corresponding to the lag compensator. So what will be the pole? 0 we know. 0 means 1 by tau. So that GC lag will be equal to S plus 1 by tau. Okay. Then S plus 1 upon beta tau. Okay. Beta we know as 2.9 approx. And pole is 0.1. So 1 by tau. Pole, this 0 is 0 of the compensator. 0 is given. So 1 by tau will be equal to 0.1. So what will be 1 by beta tau? So that will be equal to 0. That 1 by beta tau will be equal to 0.1 by 2.9. Okay. So 0.1 by 2.9 we can calculate. 0.1 divided by 2.9. So this is equal to 0.0344. Approx 0.0344. So the second option is the correct option. Is it clear to all? Just this value was given, 0 was given, beta was known. We have calculated this value, pole value, the corner frequency of pole corresponding to the lag compensator. So the correct option is 0.034. Is it clear to all? Any doubt is there? This was the last question today. So if any doubt till now, you can ask any question. Any doubt is there? Can anyone reply?
No, sir. No doubt, sir.
Okay, okay. Okay, so should we close the session or anyone have doubt with they can ask, right? Deepak, you have any doubt?
No, sir.
Okay, so thank you all. Next Sunday we'll meet same time.
Thank you, sir.
Okay, okay, thank you all.